Okay, sorry I'm zoomed out so far. We now have another system to work with, but this one's not quite ready for us to work with it. So I'm going to rearrange these equations. Let's take this first equation, bring the y and the z to the left. We already have 3x on the left. We're going to subtract the 5y to the left, add z to each side, which gives us a plus z on the left, equals 13 on the right. Moving to the second equation, we have a negative x once we do the distribution, and we're going to bring this other x over to the left, giving us negative 2x. This negative distributes to the negative out in front, so we have 1y and no more else there, so plus y. We have a minus z on the left, equals negative 3 on the right, which just stays over there on the right. Now let's deal with a third equation. We're going to have 5x after the distribution. We're going to have 5y on the left, but after we subtract the 3y over, that will become plus 2y. And then the minus 3z, when you add it to both sides, we will have a plus 3z on the left, equals negative 4. Now these three equations are in standard form. Okay, now we want to try and identify a set of coefficients that are easy to eliminate, and since the coefficients of z are 1, negative 1, and 3, I'm going to work towards eliminating them. So I'm going to take these first two equations and slide them on up here to the right, and since we already have z's canceling each other out, I don't need to change them. We will have 3x minus 5y plus z equals 13, and negative 2x plus y minus z equals negative 3. We've identified that these will already have z's eliminating because they will cancel each other out, and adding down, it appears we'll have x minus 4y is equal to 10. This right here will be one equation we're going to work with in a little bit. Now we need to somehow get this third equation involved because we've already dealt with the first two equations, and I'm going to choose to use the second and third equation and eliminate the z yet again. But this time I need a negative 3z and a positive 3z, so that first equation is going to get multiplied by 3, or the middle one I should say. So negative 2 times 3 makes negative 6x. Y times 3 gives me plus 3y. Negative z times 3 makes negative 3z equals negative 9 on the right. This bottom equation is just going to slide over. We will have 5x plus 2y plus 3z equals negative 4. And adding down, we will have negative x plus 5y equals negative 13, and that will be our second equation we will need to deal with. So I'm looking at these two equations that each have the asterisks by them, and I notice when I add them together, the x's will cancel each other out. So I'm going to come over here to the left and rewrite these red equations. That is x minus 4y equals 10, and negative x plus 5y is equal to negative 13. Adding down, we find out that y is equal to negative 3. So there is 1/3 of our answer. We now need to find another variable, and I'm going to choose to substitute this y in right up there, because that way I can identify the x easily. This will give me, coming on over here, x minus 4 times negative 3 equals 10. That is, x plus 12 equals 10. Therefore, x will equal negative 2. So now we've got our second variable. I now need to find an equation with z in it to work with. And I notice right back here at the beginning there's a single z by itself right there. So I'm going to take that equation, bringing it down here. We will have 3x minus 5y plus z equals 13. Let's substitute in the values for x and y that we have. X we know is negative 2, so 3 times negative 2 minus 5 times y, which is negative 3, plus z will equal 13. Simplifying, we get negative 6 plus 15 plus z is equal to 13. On the next line, 9 plus z is equal to 13. And finally, when we subtract 9 on each side, we get z is equal to 4. So our solution is going to be the point negative 2 comma negative 3 comma 4, where these three planes intersect. Now that's a lot of work, and you've got to be careful with your arrows that you organize your work. Certainly I could have saved myself a little bit of time right back here at the beginning and not rewritten the first and second equation together, but I wanted to show you the whole process. I think in adding the two red equations with the asterisks next to them, we could have done that kind of in our head over here without rewriting it, but still, the process is key. When you go and eliminate variables, you need to make sure when you split them apart two equations at a time that you eliminate the same variable each time.